All right, all you.
Okay, so I was part of a team that deployed an Azure environment for a client. The requirement was to fully automate the deployment of resources using Terraform, meaning there shouldn't be any manual interaction with the cloud environment after the resources must have been provisioned. We began the project, but hit a roadblock, which was to deploy an app service environment. We were using version 1 of the Azure provider, and the Terraform version was 0.11, which doesn't really support the deployment of an app service environment. I was able to get over the challenge by deploying the app service environment using templates via the Azure template deployment resource that Terraform had, and we'll be discussing about that today. So, okay. My name is Chukwukadibia Durugo. I go by Chuka. I'm a DevOps engineer at Andela, and also I work as a video streaming engineer at Pluto TV, which is a free television streaming service based off in the US. And at my free time, I get to play games and read articles and keep up with latest tech trends. So for this presentation, we're going to be looking at what templates are and at what points we need to deploy the templates with Terraform. I'll also be showing us its use case with Terraform and some important things to note about deploying templates with Terraform. We'll as well have a short demo on how I walk you through the process of deploying templates with Terraform. I'll be highlighting some deployment gotchas and also share resource down just as key takeaways. And so I'll be hanging out in the chat for questions that you may have after the presentation, so feel free to hit me. All right, let's go into this quickly. Now, what are templates? Azure, basically, Azure Resource Manager template is a JSON file, like a JavaScript object notation file. And that defines the infrastructure and configuration of your project. So basically, it's a template that has resources to be deployed specified alongside the properties of those resources to be deployed in line within a JSON file. And the template format, it follows the structure. It has the following elements: a schema file. Basically, that's kind of like specifies the location of the schema file. And then you have the content version, which basically keeps track of the content of your templates, keeps track of the versioning of the Azure templates. Then you have the parameters section, which contains values, and that's provided during the deployment of the templates. You also have the variables, and that defines the values that are reused in your templates. It can as well be constructed from the parameters values as well. Then you have the resource section. That's where you specify resources to be deployed into the environment. For instance, a virtual network, a subnet, or a virtual machine, service bus, and every one of those IaaS and PaaS resources you defined within the resources block. Now the big question: why do we need to deploy templates with Terraform? I'll recommend doing this as a last resort, where when nothing else works, because you can lose some benefits when you can lose some benefits of Terraform, especially around the state file. And I'm going to show you that in a bit. So this approach should kind of like be a last resort for you when you are unable to go through the Terraform resource provider to provision your resource. And so generally, you want to carry out this deployment approach if there are nulling arm, which the Terraform provider has no support for it. So for example, your environment requires an Azure SQL Managed Instance to be provisioned, and you may you may want to do this using Terraform, but at some point your Terraform provider, assuming you're using the Terraform 0.11 or the current release of Terraform 0.12, which still doesn't support the deployment of a SQL Managed Instance, this case will warrant you to want to make use of the templates and inject that into your Terraform script to be able to deploy such a resource. And this is a good use case to do this. And aside that, if you are deploying other resources that you can find the resource with Terraform to deploy with, absolutely, I would recommend you go through that approach. So if you don't have the feature available with Terraform and you can actually do that within any of the providers listed, then you go through the templates to carry out such a deployment. And this is a use case. The resource that Terraform provides to be able to inject your templates and deploy resources defined within the templates is the Azure RM template deployment resource. That is actually a wonderful resource to accept external template files and pass in the parameters and define the properties of which you actually want to make such a deployment. As you can see, the template deployment resource has properties like the name, the resource group, where you specify the resource group in which you want to provision your templates resources into. In this case, we have it provisioning the resources into the example resource group within the West US location. The template is injected into the template body property of the deployment resource. As you can see that it's an external JSON file with the name deploy.json. And so the deployment file is located relative to the current working directory of this particular Terraform file. And so you have the parameters section that takes in values to be sent into the templates. And those values can be like a variable that you define within your variables file on Terraform. And I'm going to show us how that plays out a bit. But then this is a structure of how the template deployment resource can be used in deploying your templates files located within a particular path in your current working directory. The deployment mode could be in two ways, either complete or incremental. Specifying the incremental means whatever resource you have defined within your templates is going to add to the resource that you already have existing in the Azure portal. And so that is not going to destroy any of the resources that it finds there. Is going to just add to them. The second deployment mode, which is the complete, will take down every other resource within the resource group that is not defined in the templates. And so you want to be very careful specifying the deployment mode that you are working with so as not to take down resources you don't really want to take down. And we're going to now go into a key and an important item I would like to mention here, and that is basically Terraform. Upon deploying template resources, Terraform doesn't have any knowledge of the content of the templates. So it cannot manage the resources in which the template provisions. Basically, Terraform keeps track of the top level template itself, but it doesn't keep track of the resources, and it's something that you should bear in mind when provisioning with templates. And I'm going to show us what that means at the course of the demo just after now. And so brace up, there's the point where I'm gonna take us down to the hands-on session to illustrate how to go about this deployments. And I'm gonna share the screen here. Right. Hey, Katie, do you see my GitHub?
I do. I see your GitHub.
Oh, great. Okay. This is a GitHub repository where I have the Terraform script we're going to be working with. But now I'm going to actually switch back to my code, VS Code. This is my code editor. I love it. And write in my code, Terraform or either any of my programming languages is a wonderful tool for code editing. Okay, so we're going to be deploying a very simple application here. This is a web app. And for note, Terraform has a resource to deploy a web app. And I chose to use the web app to try to simulate that with a SQL Managed Instance. SQL Managed Instance takes over about 2-3 hours to deploy, and that would take a longer time to do that. And then things like an app service environment, it also takes a lot of time to deploy. So, but within less than a minute, we can actually deploy this. And this is a sample to show you how you can go about deploying an ARM template. So take this template to be like the resource that is not available in Terraform, but you're trying to inject an ARM template into your Terraform scripts. Here we have the Azure template deployment resource. And so you can see we are specifying account, name, resource group. This count specifies the number of templates deployment to deploy. And here, the template body, which I talked about earlier, is the property in which you inject in your ARM template file. Now, this can actually be an inline property that you send to this template body here, or you can specify your ARM template as an external JSON file using the file function to call wherever you have your templates within your current working directory. You can see it's actually a relative path referencing the deploy.json template right here. And we'll go into the templates shortly now. And we have the parameters section that receives values. The values is coming from the Terraform variables.tf file. It's already stated this way we are getting the web app name, the SKU name, and the SKU tier. These are basically just price and tiers, and they're variabilized and gotten from the Terraform variables file. So we're passing in these values into our ARM templates as parameters. So let's have a look at the templates. It's a minimal one, right? And this, like we talked about the elements of ARM templates, it has a schema file, it has a content version, and here we have the parameters section that takes values coming into the ARM templates in which the user can set. So these variables can be coming from your Terraform tf-vars file, and you can set that at the point of deployment. So it takes these values down from the Terraform script and plug it into the ARM templates to deploy the different resources. We also have the variables section that also you have the different names of whatever you want to use a function like a concat function to give a different name for whatever resource that you are provisioning, right? You can use a function to concatenate parameter values as well and use a different way to name your web app. In this case, what we are doing is we are getting the name from the user in the variables file and also concatenating that name with another string value and passing it as a variable called web app portal name. And then we are using this variable as our web app name within the resources section here, where we are deploying the web app. So you can see the type is a Microsoft.web/site, where we have the kind and app. And then we have name. The name, we are getting the name from the variable section, which I already highlighted here. And also the properties, we specifying that it's going to be dependent upon the app service plan that we have defined at this top section right here. And then further down into the template, we have our outputs. This is going to trigger after the resources has been provisioned to give us the host name of the web app after having deployed down to the Azure portal. And so this is a simple template that we have to plug into our Terraform scripts. And we have that within our template body. Like I said, we could do this inline, like get the whole bunch of this JSON file and plug it down within this template body here, but it's not going to look so clean and it's going to actually be so lengthy. You want to actually maintain a clean code. And so using the file function is just best to make your code much more cleaner. And also I'm making use of the current release of the Terraform provider 0.12, and that is why you're not seeing me use any string interpolation mechanics for kind of like guess the variable values, because that is one of the cool features that the Terraform new release has. You can just directly call your variables without having to do string interpolation, and that's really cool stuff. Okay. Now we have every one of this defined, and I also have the service principal for Terraform created within the Azure portal. And it's something that you really want to do before you run your Terraform plan and apply, is to create a service principal in Azure and then export those. I have it currently exported within my shell environment, and it keeps track of the ID and the secrets. And if you want to actually play around with this as well, you can get your Terraform service principal created and exported or plugged in into the provider here. I'm currently using 2.0, and yeah, it's not specified on here because it's exported in the shell environment. So let's deploy this and let's see how this gets created. I'm going to move down to Terraform Cloud. I have it stated here. Hold on a sec. Let me get this here. Oh, great. I'm currently using Terraform Cloud, and I found Terraform Cloud great because it's good in terms of managing teams, working with different teams, and managing your state file. And so I have the repository integrated within my workspace web app deployment. And quickly go into the settings and version control. Down here, you could see I have the workspace connected to my repository web app deployments to Azure, which I showed you earlier. And as it's set to always trigger at the master branch upon every deploy, upon every push to that particular branch. And so I have the variables injected within the variables section of Terraform Cloud. So we have the web app name. Upon deployment of this resource, you should be able to see a resource group, HashiTalks resource group within West US 2. And these are the different pricing tiers specified basic. Deployment count is set to 0, which means our deployment templates will not deploy because it's set to 0. So I have to set this down to 1 to tell Terraform to provision a resource of this template. And so having that saved, I'm going to queue up a plan. And that should kick off moment now. All right, in less than a minute, we should see this resource getting created. And let's head to the Azure environments. I just refreshed this just to see that the resource group is not yet created yet. There we go. All right, great. Okay, so we don't have any resource as HashiTalks RG, so let's wait for our plan. And let's see, our plan is completed. Just expand this right here to see that, okay, it's gonna be creating the resource group. You could see with the name HashiTalks, getting the variables that we defined already within the variables section. And then here's the content of our templates. You can see it's referencing the templates we specified already. And you can see this is an inline representation of the templates that we have. And so it's going to provision each and every one of these resources defined within this resource section, an app service plan, and we should expect to see a web app. So 2 resources, an app service plan and a web app, and that's fine. We can go ahead and confirm this. When it's confirmed, and then it's applying. It should take less than a minute. So while that is going, let's go down to our Azure environments, refresh this. So at this point is where maybe you kind of like grab a cup of coffee and just wait for this. And so, like I already said, You should only do this when the resource you want to deploy is not available with Terraform. And yeah, you're gonna get the templates definition for that particular resource injected to the Terraform Azure Resource Manager template deployment resource that will enable you to deploy an ARM template with Terraform. And when this is created, we should expect to see the resource group, and then we should expect to see two resources, which are the web app and the app service plan. So we just have less than 10 seconds. Then we should have this all up. Great. Apply is completed within our Azure environment. I'll just refresh this here, and we should see resources created here. Okay. And there we go, HashiTalks resource group. So let's see what are the resources it created. Yeah, a sample application web app and an app service plan. Going to the deployment session within your Azure environment, we should be able to find the templates. You can see sample application deployment succeeded. Now, this template created these resources that we just observed within the resource group, a web app and an app service plan. And also we can see the output of this resource giving us the host name of the web app. You can copy that and go down to a different tab to see the application we just deployed. And yeah, this should come up within a second right now. It's loading, great. So this works. This is deployed using ARM templates. And so one key thing, like I earlier said, you need to have in mind when deploying this is Terraform doesn't keep track of these resources that are deployed within this template. What it only knows is this particular template here. You can see sample application deployment. And so if I do something like, one major challenge is if I want to take down the resource, if I have no need for the resource or it's no longer in use, or for some reason we want to actually take that down, I'll just set this count down to 0. What should happen for a Terraform resource is that resource should be destroyed. But in this case, if I queue and apply, it's going to unlink this template from this resource group, but then we'll discover that the resources are still available within Azure environment. And I'm gonna say a quick fix for that. But something that you should bear in mind, Terraform doesn't keep track of each and every one of these resources that it provisions with ARM templates, but it only keeps track of the top template level, which is this template we saw at the deployment section here. And so if I queue this plan, it's going to tell us that this template will be destroyed. But bear in mind that it's not going to destroy the resources. It will only unlink the template from the Azure environment. And so what we are going to have is we're going to have these two orphan resources not being managed by either Terraform or ARM templates. So the question is, how do I go about getting rid of these resources? Yeah, I had that challenge, and there are two ways. The first way, which I wouldn't recommend, is to take down the resource group. Definitely the resource group is going to delete all the resources in it. But you might not want to remove the entire resources within the resource group, because not all resources might not be, not all resources you want to really pull down as at that point. You just need to pull down the web app and the app service plan, right? And if you take down the resource group, it's definitely going to take down everything that you have. The next thing you might want to actually do is to write an automation script, all right, using the Terraform local exec provisioner. And that basically will interact with the Azure API to get the name of the application or resource that you want to take down. and you're going to use the Terraform hook on destroy to get those resources and kill them when it is destroying the templates. So this is completed, and if I refresh this, let me refresh this environment here. You'll see that's taken down that template, but if I refresh this right here, you can see, okay, it's coming up real quick. All right, you see no deployment. It doesn't keep track of that template anymore, but then you can still find these orphaned resources. And so either you can manually delete this, or like I earlier said, you can within your Terraform script have the provisioner, the local exec, to run when this resource is getting deprovisioned. It's going to execute something like a bash script that takes the name of the web app and the app service plan and destroy them using the Azure API. And so, or if you're actually going to destroy that from the resource group, that means you want to actually queue a destroy plan, which you might not want to do, because that is going to destroy every one of the resources within that resource group, and you might not really want that. So it's something that you should bear in mind when deploying ARM templates with Terraform. This is the challenge that is there, but then it's something that you should look through when going through this deployment mode. But then was able to help me in terms of the deployments that I had with the clients I worked with, like I earlier said about in deploying the SQL Managed Instance. I was able to do that using the template script, and I had the bash automation script that automatically deprovisions it upon destroy, and everything was fully automated. And so here we have it. I will just switch back here to my slide. Let's share this. So yeah, and here are resources that I have for us to look through and go through how Terraform deployment resource works. It has other functions, other ways to go about using the deployment resource with Terraform to deploy your ARM templates. But for the brief,
I'm still seeing your browser.
Oh, you still see my browser?
Sorry to interrupt you. Yeah, sorry to interrupt you.
Oh, let me see. Do you see my slide now?
No, not yet.
Okay. All right. How about now? You should see my slide.
I see it.
Oh, great.
There you go.
Okay. Okay, so I'll just recap. Yeah, so here are the resources that I have for us. We can actually get through this. I have the repo already within the slide, and you can hook me up within the chats, and I'll be here to answer any further questions. So thank you.